So we're back. We're going to try this style for this lesson. This is going to be essentially a review block. We're going to go through the course and think about what we've been discussing. And these are essentially the topics that we've discussed. So if this is review, we started the course looking at how to differentiate between civil, mechanical, and electrical, right? That was the goal. And what the subdisciplines of those are, civil, mechanical, and electrical. Then we started to discuss some essentially ways we learn and organize our lives. We talked about organizing our time and how to make ethical decisions and how we learn, right? So we definitely discussed how we learn. And after that, we essentially got into the design process of engineering, right? And as part of that design process, we talked some about how to lead groups in a design process, how to be a leader and how to work in a group. And then the last part of the course, we really focused on essentially doing a deep dive in all three of the areas of engineering that we had been discussing with electrical and mechanical and civil engineering, trusses. So that's what the course has been about. Please don't make it so that if the topic did not appear in my list here, it didn't exist. Each of our lesson blocks, we had learning outcomes, and as we work our way toward the final exam in this class, those are the things that are essentially in play for that final exam. So what I'm going to do next is I'm going to do a little deep dive in each one of these areas by way of review. So we'll jump right in. We started the course with differentiating between civil, mechanical, and electrical engineering. In civil, we identified these 7 subdisciplines, right? Where we had structural, geotechnical, transportation, hydrology, environmental, construction management, and surveying. So those were the 7 subdisciplines, right, of civil engineering. And we talked about how civil engineering is primarily or often associated with public works. So that's sort of the review of civil engineering. And again, just because I don't cover something in this review period, we did a lot in this class. We're going to do a short little review. In mechanical engineering, we basically broke mechanical engineering down to 5 different fields: mechatronics and robotics, thermofluids, mechanics and materials, manufacturing and machines. But we definitely noted that mechanical engineering is by far the broadest of the disciplines. I would say many would look at things like biomechanics, biomedical engineering, or aerospace engineering as being part of mechanical, perhaps. Another way of sort of describing mechanical engineering is essentially, design and manufacturing, right? To get to the marketplace for any object. So mechanical is pretty broad. So we did spend some time with mechanical engineering. I bet you knew what was coming next. That's right, we're going to talk about electrical engineering for a moment. We basically wrapped our brains around the idea that electrical engineering is essentially dealing with the physics and math of electricity, electronics, and electromagnetism. So we talked about that it covers things like power and control, electronics, electronics and microelectronics, signal processing, all kinds of communications and instrumentation, of course, circuit design. But we also acknowledged that some things that one might not think of as being electrical engineering, a lot of people think are in play there. Things like software engineering and even computer engineering, computer design, that sort of thing can be considered part of electrical engineering. Pretty broad field. Okay, so we're going to shift gears for a little. That was the basics of how we introduced the course. Then we started talking about some things like time management and how to manage our priorities and that sort of thing. And we really talked about lots of different things, but one model that we looked at was this idea of trying to organize our lives into 4 quadrants, things that are, urgent and important, all the way down to things that aren't really very urgent and not all that important. And the basic idea is essentially we kind of want to control quadrant 2, which this stuff which is, essentially maybe it's not urgent, but it's important. We have to get to it. And we are going to control that by the best we can, eliminating things in quadrant 3 and 4, things that, essentially aren't important, whether they're urgent or not urgent. They're still essentially not important. And that's the idea of, let's focus our lives on the things that are important. And, it's up to all of us to decide essentially what those important things are. But for me, it's God, family, friends, in basically that order. So, and then work and some of those things come next. Those are the important things in life for me. You have to define that for you. We spent some time on ethics, morals, and values, for sure. And I'll basically just leave you with the UT Tyler Honor Code for this one. Do you remember what the UT Tyler Honor Code was? I will not lie, cheat, or steal, right? Nor tolerate those who do. Essentially, it's bad enough if you're going to do it yourself, but we really shouldn't be aiding or abetting those who do. The basic honor code. Essentially, if we're going to be engineers, we need to do it with honor. Next, we jumped into the ways we learn, and we talked about 3 ways of learning: psychomotor, affective, and cognitive learning. And essentially, we can have quick definitions of those. Psychomotor is the physical, affective is the emotional things we learn, and cognitive is the intellectual things we learn. And essentially from there, we really focused on the cognitive domain, right? And we looked at actually Bloom's taxonomy of the cognitive domain, where as things get, when we first are exposed to things, we can get new knowledge, remembering, defining, that sort of thing. And we get a little deeper, and then we could explain those things or summarize them, describe them, discuss them a little more deep, and then we can apply them, use them to produce things or predict things. Keep more and more advanced thinking. We can use our techniques to analyze things, compare and contrast, calculate, and finally we get really advanced level thinking where we're designing or even judging designs to determine which ones are best. And as we mentioned, there's some controversy about maybe what order these might come in. Some will reverse these two, especially the last two. But it's good to think about the ways learning and information is organized in our own brains. And along those lines, organization of knowledge in our own brains and how it gets there, we talked some about learning styles, right? And the idea that some of us are visual learners, some of us are verbal learners, and so forth. Various axes upon which we learn. Some of us are very active learners. Some of us want to sit back and reflect. Some of us organize things sequentially. Some look at big picture first and then fit facts into that framework, that sort of thing. Next, we covered leadership, and we talked about leaders having vision and integrity, got to be consistent, and empathy, the ability to put yourself in others' shoes. As we work in groups, some will lead, some will follow. In order to be a good leader, sometimes you have to be a good follower. Certainly in group work, we need to know how to set goals. We talked about the SMART system, right? The idea that goals need to be specific, measurable, have some sort of action plan, be realistic, and have a timeline. So we did that work in preparation for working in our groups and actually working on the engineering design process with our big activity through the semester. And as we talked about the engineering design process, I presented lots of different models for that. I presented, a very simple one, which was simply, essentially, analysis and design, and the decisions that have to get made in design are impacted by our analysis assumptions, but those assumptions are impacted by what we've designed, and it was a circle that went round and round. We also talked about the Project Lead the Way design model, and I'll let you go back and look at that, or Google the Project Lead the Way design model, or you've probably seen it by now many times. We also talked about the 9-phase process that I presented, and across those, one of the features I wanted to get across to you is the idea of the 9 engineering constraints that we use here a lot. And they're, constructability and health and safety, economics, environment, politics, social, ethics, technology, and sustainability. Those really do tend to impact our design in lots of ways. No matter what product, whether it's a computer we're designing, or a roller coaster, or a bridge, they're in play. So we definitely talked a lot about engineering design process. I recommend you take a look at that stuff. And with that, I'm going to stop and break the video here so it doesn't get too long and too bulky for you to download. What I'll be doing next is an example problem in electrical, civil, and mechanical engineering in each discipline to remind you of some of the principles that we used as part of our deep dives.